Hello everyone, welcome to Study Guide Forum. Today we'll be looking at the volumetric analysis in preparation for um, 2024 Waec chemistry. So in this very titration is a type of titration we call redox reaction because it has to do there is no acid here and there is no what base. What we are doing here is just um, a an oxidizing agent against what a reducing agent. Potassium permanganate is an oxidizing agent, while iron 2 tetraoxosulphate is what a reducing agent in this reaction. But what happened? Um, at the end, they don't have any indicator. Rather, they this is the type of reaction they say is what self. It has a self indicator. It has a self indicator. You understand? It's a self indicator in the sense that the color change of potassium permanganate will tell you the end of the reaction. Now, in this question, already I just want to skip some things in order to make it easier for us. So here we have a question, a possible question. It's not likely to be the one that you cover. I'm trying to use this to really understand, to help you understand the possible question and how you can handle some questions and when you see them in the exam hall. So here we have A is a solution of potassium tetraoxopermanganate, permanganate 7. B is a solution of iron 2 tetraoxosulfate 6 containing 2.75 grams of salt in 500 cm cube of the solution of solution. Now from results, which is one of these things we have here, the volume of the titer, the volume of the titer, the table here we have, and then these are the from our result and information given provided for us. We have to calculate the concentration of B in mole per dm cube, and then we calculate the concentration of A in mole per dm cube, and the number of moles of iron iron 2 iron 2 iron 2 ion in the volume of B pipetted. Now we have the chemical equation, ionic equation, the balanced ionic equation of the reaction. This is the table. And then now the first thing we're going to do here, looking at this table, the first thing we're going to do here is to calculate the average volume of the what of the A used, which is the oxidizing agent. The average volume of the A used. When we do that, remember the average volume of A will then be now if you look at it, you are likely to take the ones that rhyme, you understand, that are consistent. If you look at it, we have a and they are very close to each other. We have a we can use the two of them, first and second. Normally we don't normally use the rough. We don't normally use the rough. So since this one seems to be rhyming together, we're going to be the difference are normal. We're going to use 18.1 plus 18.2 divided by 2. So when we divide it by 2, what do we have? We have a 18.1 plus 18.2 divided by 2. We have 18.15 cm cube, which is the average volume of the oxidizing agent, which is the A we use in this thing in the titration. Now the next thing they ask us to do is to find the concentration of B in mole per dm cube. The concentration of B in mole per dm cube, if you look at this, we have this in 500 cm cube, and we have the mass of the salt contained in 500 cm cube. Rather, what we normally work with what 1000 cm cube or 1 dm cube. So now what we do here is to the next thing we're going to do, we are going to find the mass that is contained in 1000 cm cube. Now we are told that 500 cm cube contain 2.75 grams. Therefore 1000 cm cube will just be 2.75 grams divided by 500 multiplied by 1000. This one will go. We have a now 1 1 we have 5. So The next thing we are going to do here, just to be sure, we have 2.75 times 1 divided by 500. We have this is the grams we have. So what we have here is 5.5 grams. Now, say that we're going to calculate the concentration of B in mole per dm cube. Now, we know what we have there is to be 18.15. Lest I forget, I'll just clean that right away. Let me write it down here so that I won't forget, because we will still come to that. So remember, we know that mass mean mole is equal to mass over what? Molar mass. So now we have the mass, the relative molecular mass of B, that is the reducing agent, is this. So we can then go by that. We have 5.5 over 152. That will give us 5.5 divided by 152. We have what we have will be equal to 0.036 mole. That is what we have here. Moles, that is what we have. Then we can say mole per dm because everything is believed to be what? In solution. We can say mole per dm cube. Now, what next are we going to do? We have been able to solve the first question here. Now we have the number of moles, molar concentration in mole of B in concentration in mole of B in mole per dm cube of B. So now the next thing we are going to do is to go ahead and solve the other ones we have. So the other ones, the second question there says that concentration of A in mole per dm cube, concentration of A in mole per dm, concentration of A in mole per dm cube. Now we can use our relationship. Our relation, this says that A, Ca, have a Cb and Bb equal to A and B. So from our chemical equation, we have the reducing agent. The reducing agent here is 5. So we have B here will be what? Equal to 5. And then for the oxidizing agent, we have 1. That means 1 here. Then for the concentration, we don't know this one. We don't know this. But we know the volume used. The volume we use here is what? 18.515 cm cube. 18.15 cm cube. And the volume of B used normally, what I use in this is what? 25 cm cube. Then concentration of B in mole per dm cube, we have 0.035 mole. No, 0.036 mole per dm cube. So that is what we have. So in that case, we are going to substitute for all those things that have been listed out there. So what we have, concentration of this is unknown. This is volume is 18.1215. 18.15. The concentration of B in mole per dm cube is 0.036. Volume is what? 25. So their mole ratio, A is what? 1 and B is what? 5. So what we do next, we make Ca the subject of the formula, the one we are looking for. If by multiplying this, if we cross multiply that, we have 0.036 multiplied by 25, then 18.15 times 5 times Ca. Then Ca being the subject of the formula now, we have 0.035 times 25 all over 18.15 times 5. So now, if we multiply through, we have 25 multiplying 0.036 divided by 18.15 and then divide by 5. What we have here is we have 0.0099. That would be mole per dm cube. That would be approximately we will have a 0. Adding up to have 0.01 mole per dm cube. That is what we have. So that is the for the second question. Now we have been able to get the second question. The next one they said they should find out that is the number of moles of iron 2 ion in the volume of B pipetted. Now to get this thing done, we know that in 1 dm cube of this solution of the reducing agent, in 1 dm cube of the solution of the reducing agent, we have 1000 cm cube, which is something as 1 dm cube contain what? 0.036 moles. Okay, let's leave this moles already. So the volume of B pipetted is 25. That means 25 cm cube. 25 cm cube will then be 0.036 divided by 1000 times 25. So when we do that, what we have is 0.0 multiplied by 25 divided by, we have the volume, the number of moles there will be 0.0009 moles of what? Of iron 2 ion. Of iron 2 ion. That is what we have. So thank you so much for being part of the class. And then if you have not subscribed, we will encourage you to do so. And we like to, if you have any question, just make sure you leave it as a comment. We can always attend to you. Thank you so much.